All right, guys, so what we're looking at is the remaining part of the notes that we didn't go over together um, in class. So I'm going to do it here on this video, and then you can watch it and copy down the notes. So on this page, we did 16, 17, 18, and 20. So I'm going to do 19 with you. Once again, if it doesn't look like the 6 trig integrals that we know, remember that's the integral of sine, the integral of cosine, the integral of secant squared. All right, these all have a du at the end. The integral of secant u tangent u. Like I said, my handwriting isn't the best with this, but better than nothing. So secant u tangent u. The integral of cosecant squared, and the integral of cosecant u cotangent u du. All right, if it doesn't look exactly like one of these 6, you can't just make u the inside. You have to think bigger. So if you have a parenthesis or a square root, a trig function inside, the best thing would be to rewrite it as the whole thing raised to the power. So in this case, it would be to the 1/2 because it's the square root. All right, and what you're going to make u here, remember we have a dx also. What you're going to make u here is the inside of the parenthesis, which is cosine 4x. The derivative of cosine is negative sine 4x dx. And then you have to multiply by the derivative of 4x, which is times 4. That's chain rule that you're applying. So in green, I'm going to highlight that like we basically already have our du in there except for this -4. So it's no big deal. I'm going to put in a -4 as long as I compensate and multiply by -1/4 on the outside. And when I do that, I'm going to get the integral of this parenthesis here. This is my u. It's going to be u to the 1/2. And the rest of it underlined in green is my du. And now I'm just applying simple power rule to this. So this would be u to the 3/2, and divided by 3/2 is the same thing as multiplying by 2/3 plus c. And then you reduce what you can. This 2 and this 4 reduces to a 1/2. And when you take the 1/2 and multiply by 3, you get 1/6. You're going to plug your u back in, which is cosine 4x. The whole thing to the 3/2 power plus c. All right. So we did example 20. We are going to look at example 21. So once again, I can rewrite this as cosine 3x, the whole thing to the parenthesis 1/3 power on the bottom there. And I think you'd agree with me in saying it does not look like any one of these off to the right. So you got to think bigger in terms of your u. My u is going to be the whole inside of that parenthesis, which is cosine 3x. And the derivative of cosine is negative sine 3x times 3 dx. Okay, I'm running out of room there. All right, you have to use chain rule for that. That's why there's that extra times 3. So I'm going to highlight this in pink. The sine 3x dx is already in the problem. We just need the -3. So I'm going to put in a -3 and multiply by -1/3 on the outside. And that's going to give me -1/3. The integral of du's on the top, u to the 1/3 is on the bottom. So that ends up being -1/3, the integral of u to the -1/3 times du. And we integrate this with normal power rule. So it becomes -1/3 u to the 2/3 when I add 1. And remember, when we divide by a fraction, we multiply by the reciprocal. It's a multiplication symbol. The 3's will cancel. I'm actually left with -1/2 out in front. And that's going to be cosine 3x all raised to the 2/3. Plus c. All right, so moving this down, we have example 22. Anytime we saw 1 over cosine squared before, so 1 over cosine squared, we rewrote it right away as secant squared, because you can't integrate 1 over cosine squared. And the same thing as 1 over sine squared. We're rewriting it to something we can integrate, and that would be cosecant squared. So this, I'm going to rewrite as secant squared 9x dx. So I'm going to pick my u, okay? Now, this one, okay, looks like, and if I move this up, it looks like this one right here. So that means you make u just 9x. So I'm going to make u the inside, 9x. My du is 9 dx. So I don't have a 9 in there. I'm going to put a 9 in. Doesn't matter where you put it. So that's going to be my du. But I have to compensate and multiply by 1/9 on the outside. And now I'm turning this into the integral of secant squared u du. And secant squared integrates to tangent, because we know that formula. Integral secant squared is tangent u, which I'm going to plug back in right now, plus c. All right, and let's look at the next one. Take a look at 23. This does not look like any one of these. It looks close to this last one, but this last one's not raised to the second power. This is. So you have to think bigger. So what we want to do is we want to rewrite, if there's any trig function raised to a power, we want to rewrite it as the whole thing raised to the power. That's most of the time helps us. Now we have to pick our u that when we take the derivative of it, it's basically in the problem already. Well, the derivative of cotangent, and you can actually do this problem in 2 ways, but I'm only going to tell you one way because I don't want to confuse you. The derivative of cotangent is cosecant squared. So your best bet is to make u cotangent. And the derivative of cotangent is negative cosecant squared 2x times dx. I'm running out of room there. Times dx times 2 because of the chain rule. And look at this. The cosecant squared 2x dx is in the problem. See, it's right here. So all I need to do is plug in a -2. So I'm going to just plug in the -2 back here because I'm running out of room in the front. And then you multiply by -1/2 out front. And this ends up being, let me choose a different color, -1/2, the integral of u to the second, and what I have underlined in green is my du. So all you have to do is power rule now, so that's u to the third over 3 plus c. That's a 3, guys. And then your final answer would be -1/6. My u is cotangent 2x raised to the third plus c. So your answer is right here, -1/6 cotangent 2x to the third plus c. All right, and how did I know to pick cotangent and not cosecant? Because I know the derivative of cotangent is cosecant squared. It's already in the problem. So it's easiest making u cotangent. All right, now, with example 24, all right, I'm going to rewrite this. It doesn't look like one of these. It looks similar to the last one, but this is not raised to the 6th power. So I'm going to rewrite this as cosecant 3x, the whole thing to the 6th power times cotangent 3x dx. Now, okay, with our u here, all right, you would most likely try to pick u the inside of the parenthesis. Here we could have done it, and you're going to see the method we use here. We could have also done with example 23. But let me explain why picking the same u as 23 isn't going to work for example 24. If I make u cotangent, the derivative is cosecant squared. Well, you have cosecant squared, but what are you going to do with the extra 4? You can't take du and raise it to a power. Du should stand alone, and it should never be raised to a power, and it should never be in the denominator. All right, so if you have stuff left over and you don't know how to replace it, that means you picked the wrong u. 90% of the time, your u is going to be the trig function inside of the parentheses. The derivative of cosecant is negative cosecant cotangent times the derivative of the inside, which would be a times 3. And then you have a dx. Now, look at this. You have a cotangent 3x dx already in there. And you have enough cosecants to go around. Watch what I'm going to do here. I'm going to borrow one, just like we did in another example above. I'm going to borrow it and make it to the 5th power. And then I'm going to write one right next to the cotangent. And right here, that's basically everything right here, except for this negative 3. So no big deal. I'm going to put in the negative 3 that I want and multiply by negative 1/3 on the outside. Okay? And now that gives me negative 1/3, the integral of u to the 5th, and the rest of this right here is my du. So you're integrating this with normal power rules. So it'd be u to the 6th over 6 plus c. And the last step would be to simplify it. So it'd be negative 1/18 u, which is cosecant 3x. You're going to raise the whole thing to the 6th power plus c. All right. So we're actually going to end there. You've seen plenty of examples to just be able to practice it now. And that's what it takes is practice, 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 practice. It's the only way that you're going to get good at this, at recognizing what's your u and is your du in there.